Okay, fourth degree polynomial leading coefficient is a positive 1. If this is the x-axis, I know it's going to be shooting up at some point and shooting up at some point over here. It's in between, I don't know much about it. So what I want to do is just, basically write down the function f of x, and that's x4 plus 2x cubed minus 5x squared minus 4x minus 6. And let's just look at the signs, right? We're going to use the Carr rule of signs. Plus, plus, minus, minus, minus. And there's only one sign change here. So s equals 1, which means p must be equal to 1. It must be. So then the question becomes is, what are you going to do about that? Well, I got to start to evaluate the function to find out where it's going to get, it's getting that root. And the way I do that is I write some numbers down. Now let me see if I did that. I guess I didn't do that. Okay, let's go back and do it then. So they want to show a root between 2 and 3. So if that's the case, all I have to do is show that they change signs. So I'm going to write this down for you. F of 2. And what's f of 2? 16 plus 16 minus 20 minus 8 minus 6. Well, that's definitely negative. So f of 2 is below 0. Let's do f of 3. Let's see if we can do that. Well, let me write over here. I need some room. 81, 54, minus 45, minus 12, minus 6. Definitely positive. What do I know? Between 2 and 3, at 2 we're negative, and at 3 it's positive. And remember, Descartes' rule of signs says there's only one root. It's between 2 and 3. That's what they asked us to show. We just showed that. Now it says at least one between minus 3 and 4. So I'm going to use Descartes' rule of signs again. And what do you get over there? F of minus x equals x4 minus 2x cubed minus 5x squared plus 4x minus 6 plus minus minus plus minus. All right, let's take a look. What do you get over there? Well, let's see. You get one change here, one change there, one change there. So s equals 3. So p could be 1 or p could be 3. So we either have one negative root or 3 negative roots. All right? So what I need to do is, I guess I need to analyze it again for what's going on here. But I got a general idea, and I'm going to start to erase a lot of this stuff over here. By the way, this is not the picture. We go through that if you want, but that's not the picture of it. And I'll erase this too. I'm done with that. And what I do know I know at 0, this thing is negative. By the way, at some point, it's got to be going back up. All right, I know that much. Okay. I know it's tough, but you got to go through some numbers. I want to see if I evaluate. Oh, yeah, I did. So at minus 3, it's negative. At minus 4, it's positive. All right. I don't think I did the other ones, though. And I probably should. I did some other analysis over here, though. But let me go through this. A little bit easier for me. I want to see what happens at minus 2. and at minus 1. All right, not that bad, right? What do you get? 1 minus 2 minus 5 plus 4 minus 6. Clearly negative. How about at minus 2? 16 minus 16 minus 20 plus 8 minus 6. Clearly negative. All right? What do I know? It's puncturing here. According to the Descartes rule of signs, though, it's either once or 3 times. All right? So I got that covered. All right? Now, granted, I know I went through some other work over here about this over here. And again, I'm not saying it's bad to do that. It's been a while since I solved this problem. But I think I would have used Descartes' rule of signs. And it's kind of nasty, the algebra. And also, in the end, if I say, you could also use Descartes' rule. All right? I did that. All right? Again, if you need to reach out to me, my name is Ron Bannon. Email address is Bannon, B as in boy, the @ symbol, NNON.US. Now, you may be curious about my solutions guide. This was written, this document took me years to write, and I just can't remember how long ago I wrote that solution up there. But it was probably at that particular point in time, after reading the section, I felt that was the appropriate strategy. All right? However, currently Descartes' rule of signs is on my mind. It really depends what's on my mind to solve a problem. All right? Thank you for paying attention, though.